Hello grade 9s, my name is Natasha Barton and today I would like to welcome you to this video in which we will practice how to simplify algebraic fractions using factorization. If ever you've wondered why we learn how to factorize, one of the reasons is so that you can simplify algebraic fractions successfully. That said, grade 9s, it is so important that before watching this video, you know how to identify the highest common factor and how to factorize by taking out the highest common factor. You also need to know how to identify and factorize the difference of two squares and how to identify and factorize trinomials. If you have not mastered these skills, it's important that you watch the videos on each of these topics and that you practice using the worksheet and memo available on the Junior Techie website. If you have not mastered these skills, you may find this video challenging to understand. But if you believe that you're ready, then go ahead and watch. Let's hop into the first problem. This problem says, use factorization to simplify b squared plus ab divided by ab. I like to tell my learners to start off by drawing brackets around the numerator and brackets around the terms in the denominator. This is a reminder to ourselves that we are dividing everything at the top with everything at the bottom. We now need to factorize by making use of the tools that you learned in the previous videos, remembering to start off always with the highest common factor, if there is one. We look for the highest common factor in the numerator and then in the denominator. In the numerator, we identify the highest common factor as b, and we can now factorize out b. We say b squared divided by b, and we are left with b. We say positive AB divided by B, and we are left with positive A. Now, if you take a look at the denominator, you'll realize that there we only have one term, so we will not factorize AB. We now identify common factors between the numerator and denominator. Do you realize B is common because it is a term, one of the factors in the numerator and one of the factors in the denominator. So now we can cancel the b's. You might wonder why we do so. To make sense of this, I would like to make use of that simple fraction at the bottom left-hand side of your screen, which says 15 over 3. You already know that the answer to this is 5, but this is truly the reasoning behind it. 15 is 3 times 5, and if we divide that by 3, can you see that 3 is common in the numerator and denominator? We can therefore cancel the 3's and we are left with 5. So we cancel the b's and we are left with b plus a, which was in the brackets, over a. Now you might be tempted to cancel the a's, but be very careful. If you cancel the a's, you are 1010% incorrect. Please do not do so. The reason is because we are dividing everything at the top with everything at the bottom. And since A may be common, it is not common between the terms at the top. So if we cannot divide B by A, then we can't divide the A at the top by A. And therefore, what we have written down is the answer to this problem. The second problem reads, use factorization to simplify 4a squared minus 9 over 4a squared plus 6a. As normal, I always encourage you to draw brackets around the numerator and brackets around the terms in the denominator so that you remember we are dividing everything at the top by everything at the bottom. Now we remember the tools that we can use in order to factorize to simplify, always starting with the highest common factor. We look at the numerator to see if there's a highest common factor, and there is no highest common factor. But there's definitely a difference, a negative sign separating the terms. The first term is a square, and the second term is also a square. So that means we have the difference of two squares. We write our two brackets, one with a positive sign and one with a negative sign. The first term in each set of brackets is 2a because the square root of 4a squared is 2a, or in other words, 2a multiplied by 2a is 4a squared. And the second term in each set of brackets is going to be the square root of 9, which is 3. Now we can take a look at the denominator. The denominator is 4a squared plus 6a. We start off again with the highest common factor to see if there is one. Now between 4 and 6, which is the coefficients, there is a highest common factor, which is 2. We now look at the coefficients to see, the variables, to see if there's a common variable. There is a common variable, a. Now we need to write a to the lowest exponent. We have an exponent of 2 and an exponent of 1. 1 is smaller than 2. Therefore, the highest common factor here is 2a. We're going to factorize that out. And when we factorize it out, we are left with 2a plus 3 inside of the brackets. We have factorized both the numerator and the denominator as far as we possibly can. So there's nothing more that we can do to factorize either the numerator or the denominator. So now we need to look for factors that we can cancel, factors that we can basically divide at the top and divide at the bottom. Remember, you can only cancel terms in the numerator with terms in the denominator, or factors in the numerator with factors in the denominator. Can you see that 2a plus 3 is a common bracket? Therefore, we can cancel it, or in other words, we can divide the top by it and divide the bottom by it. And then we are left with 2a minus 3 at the top in the numerator and 2a in the denominator. Now again, you might be tempted to say the 2a in the numerator divided by the 2a in the denominator and to cancel these. But please remember, you are dividing everything at the top by everything at the bottom. And since negative 3 is not divisible by 2a, it means that this here is the final answer and we cannot simplify any further. The last problem in this video says use factorization to simplify one big fraction by another big fraction. And remember, I always encourage you to write brackets around your numerators and denominators to remind yourself of what you may not do. Now I want you to notice that there's a division sign in between the two fractions. What rule are we supposed to use when we have a division sign between two fractions? Well, you change the division sign to a multiplication sign and you find the reciprocal of the second fraction. In other words, we are now going to tip and times. That's the first thing we're going to do before we even start to factorize. So we rewrite everything exactly as it is, except now the division sign becomes a multiplication sign and the second fraction is tipped over. Its denominator becomes its numerator and its numerator becomes its denominator. Now that we've done that, now that we've dealt with that division sign, we can start to factorize. We start off by taking a look at the numerator of the first fraction, which is y squared minus 6y. Always start off with a highest common factor. Here there is a highest common factor of y, and when we factorize it out, we are left with y minus 6 inside of the brackets. We now look at the denominator here in the first fraction. Always starting with the highest common factor, but there is no highest common factor. We check to see, is there a difference of two squares? There's no difference of two squares, but there's definitely a trinomial. So we will factorize it using what we know about trinomials. Since the last term is negative, we know there'll be a plus sign and a negative sign in the brackets, different signs in the brackets. The first term is y because the first term in the trinomial is y squared. And we then look for factors of negative 18, which when added together will give a negative 3. And that is negative 6 and positive 3. In writing this down, we factorize that trinomial successfully. Now we need to move on to the next fraction and start off by factorizing its numerator. We look for a highest common factor, and there is one, it's 6y. We factorize that out and we are left with y plus 3. Then we move on to the denominator. Here we have one term that is squared. So to just make cancelling everything out easier for us, we're going to expand this and write minus 2y multiplied by minus 2y, because that's the meaning of negative 2y squared. We just have the same thing multiplied by itself. So now that we have factorized everything completely, we can look for factors in the numerator that are the same as in the denominators, and we can cancel them. Since we have two fractions, we can use a method called cross-cancelling, which is where you are allowed to cancel the numerator of the fraction on the left with the denominator of the fraction on the right, and vice versa. So first off, notice that in the fraction on the left we have y plus 3 in brackets, and on the right we have y plus 3. So we can cancel that out. We then have y minus 6 and y minus 6, which is common, and we can cancel that out too. Then the y in the fraction on the left can cancel with one of the y's in the denominator on the right. The y at the top of the fraction on the right can cancel out with the other y at the bottom in the denominator on the right. We are now left with only a 6 at the top and a minus 2 multiplied by negative 2 at the bottom. Now 6 is divisible by 2, so we say 6 divided by 2, and we are left with 3 at the top, and at the bottom, in the place of the 2, we simply have a negative 1. We no longer have factors that can divide into each other, so we are therefore left with 3 in the numerator, and negative multiplied by negative 2 is positive 2. Again, 3 divided by 2 cannot be simplified further. So this, ladies and gentlemen, grade 9s, is the final answer to this problem. And in doing this, we have completed this video. I hope that you've enjoyed watching it as much as I've enjoyed putting it together. Please remember to practice as much as you possibly can, and to watch the next video in this series of videos on factorization.